Here is a problem from section 3.4, problem number 5. It's asking us to take a look at this data and one, graph it, and then two, see if we can get some estimates about about the derivative function. So let's do the graphing part first. Let's make this 1, 2, 3, and 4. Let's go up to, well, we have to go up to 50. So let's call this 20, 40, and then that means 50 would be right there. All right, so at time equal 1, we're at 12.5. Here's 10, 12.5 is about there. Oops, at time 0, we're at 12.5. Let me correct that. So at time 0, we're at 12.5. So here's 10 called 12.5 right there. At 1/2, we're at 26. So here's 30. 26 is about here. At 1, we're at 36. Let's call that about here. At 1.5, we're at 44. Call it there. At 2, we're at 48. At 2.5, we're at 50. At 3, we're at 48 again, and then 44. At 36.5 again, so on and so forth. Okay, so there's our plot of t versus s, and we should probably label this axis as t, and then this axis as s. All right, now assuming that there's a smooth curve here, can we find and get an estimate of the velocity at time equal 1? Well, here's time equal 1, and we could draw a tangent line through this point. But probably what's better is to go back to that n-deriv definition, where we say, you know, if we want an estimate of the function f at a, then maybe what we should do is take f of a plus h minus f of a minus h, and then divide that by 2h. What that means in this case, if we want to get an estimate at 1, maybe we should look at the values on either side of 1 and do a secant line slope between those. So my estimate of the velocity at time equal 1 is going to be equal to the value of s at 1.5 minus the value of s at 0.5, and then I'm going to divide by the length of that gap, which is 1, or 1.5 minus 1. So the value at 1.5 is 44. The value at 0.5 is 26. 1.5 minus 1 is 1. 44 minus 26, well, 46 minus 26 is 20, so this must be 18. And don't forget to put in our units, in this case feet per second. What about the velocity when time is 2.5? And again, I'm going to take 2.5, I'm going to grab the secant line from either side of there. So how about the value of s at 3 and the value at s at 2, and of course we're going to do 3 minus 2 on the bottom. The value of s at 3 is 48.5, the value at 2 is 48.5, and that's all over 1, and that gives us an estimate of 0 feet per second. Now you may notice that the secant line here actually does mimic that tangent line slope of 0. And then lastly, what's our estimate of the velocity at time equal 3.5? Again, we're going to go a little bit higher, and then a little bit lower, and then it's going to be 4 minus 3. The value at 4 is 36.5. Value at 3 is 48.5. And that's going to be divided by 1. That's what? 3.5 plus 8.5. That's what? Negative 11? No, negative 12 over 1. So how about negative 12 feet per second? And if we take a look at, again, the secant line slope between those 2 points, or the tangent at that point at 3.5, you see that that has a negative slope, and our estimate of velocity at that point is also negative. So there we have it, problem number 5.